Okay, let's take a look at concept 1 here, mean, median, mode, and range. On number 1, we're asked to find the value of x so that this 1, 2, 3, 4, 5 numbers has a mean of 114. Let's go ahead and set up the formula. Mean, or average, is equal to the sum of the data divided by how many? So our average is 114. The sum of the data, if we add it all up, the 90 plus 130 plus 96 plus 123 plus the x is 439 plus x divided by how many? 1, 2, 3, 4, 5. Let's go ahead and multiply both sides by 5. If we multiply both sides by 5, 5 times 114 is 570. That equals 439 plus x. And then subtract the 39 from both sides. The result there is 131. So x would have to be 131 for this set of data to have a mean of 114. Number 2, we need to find the mean and the range. Let's see, the mean is just, again, add them all up and divide by how many. When I did that, I got 20. So that's just adding 25, 21, 26, 11, 15, 10, 14, and 38, and dividing by what? 3, 6, 8. I got 20. The range is the biggest number minus the smallest number in the list, so 38 minus 10 is 28. So I got a mean of 20 and a range of 28. Number 3, your math teacher allows you to use a measure of central tendency. That would be either the mean, the median, or the mode to pick your test grade. We have these test scores so far, actually to pick our grade in a class. We want to know to the nearest whole number which measure of central tendency should we choose, and we're implying here that you want to get the highest possible grade. So we need to calculate a mean, we need to calculate a median, and we need to calculate a mode. Well, mean, we've been doing that so far. Just add them up and divide by how many. I got 80 point approximately 67. The median, if we put these numbers in order, 74, 76, 77, 80, 87, and 90, and then we look for the middle number, which doesn't really exist because we have 3 below and 3 above. So what we do is we just take the average of these two guys. The average of those two guys is 78.5. And then the mode, well, no number happens more than once, so there really is no mode. Therefore, we would say that we would take 81%, rounding to the nearest whole number, which would be the mean. So we'll tell our teacher we'll take the mean at 81%. That'll give us our best possible grade. On concept 2 here, we start solving equations. For this one, I would probably start by adding 3 to both sides. That gives me 2/3 x equals 8. Let's go ahead and multiply both sides by 3 then to get rid of this division by 3. That just reduces out on the left, gives me 2x equals 24. Then finally divide by 2, and x will be 12. So number 2 is done. Number 5, we're solving for d. Let's go ahead and subtract 20 from both sides. That'll give me negative 8 equals negative d, but I don't want negative d, I want positive d, so let's divide both sides by a negative 1, or you could multiply if you choose, and I get d is equal to 8. So number 5 is done. If we plug that back in, we'll check it. Negative 8 plus 20 is 12, that equals 12, so that checks. It has to be right, it can't be wrong. Number 6, since 3 goes into 39 evenly, let's just go ahead and divide both sides by 3. And that'll give us y plus 7 equals 13. And then we can subtract that 7 from both sides, and y is going to equal 6. If we plug that back in, 6 plus 7 is 13, times 3 is 39. That checks. And number 7 on this concept. Let's see, I've got x's on both sides, I've got numbers, constants on both sides. Let's see what we can do to clean this up a little bit. Let's subtract 2x from both sides. That'll give me negative 6 equals 2x minus 8. Let's go ahead and add that 8 to both sides to isolate this x on the right. That'll give me 2 equals 2x, and we can either divide by 2 or just see by inspection that x would have to equal 1. If we try that, 2 minus 6 is negative 4. That's a value there. 4 minus 8 is also negative 4, so since both sides equal negative 4, this checks. It has to be right. It can't be wrong. Number 8 asks us to do a couple things. It said write an equation and then find the values of the two integers. So there's two things that we're looking for there. We have the sum of two integers is 51, two consecutive integers. Well, if the first number is x, the second number has to be x plus 1, because consecutive integers differ by 1. It says if I add these together, that has to equal 51. So there's the first part. There's an equation. That takes care of this part. Now I just need to solve it and find the two numbers. Well, if I add the two x's together, I have 2x plus 1 equals 51. If I take the 1 away from both sides, I have 2x equals 50. Divide by 2x is 25. Therefore, my first number is 25, and my second number, according to this, is just one bigger, which would be 26. So 25 and 26 are two consecutive numbers that add up to 51. Okay, this is my work on this problem. We've got two bicyclists that pass each other at 9 o'clock. At 10:15, they're 23.75 kilometers apart. It's a classic rate times time equals distance problem. We'll go ahead and set up the table here. It says that the bicyclist riding north is 3 kilometers an hour faster than the one riding south. So the one riding south we know nothing about. We'll go ahead and put x there because we don't know it, so we'll just put an x there. The one going north is going 3 faster than x, so that's x plus 3. The time between 9 and 10:15 is 1 1/4 hour, 1.25, or if we choose to use fractions, and I did, 5/4 hours. Rate times time equals distance. Therefore, x times 5.4 is 5/4 is 5/4 x, and x plus 3 times 5/4 is 5/4 times the quantity x plus 3. Right here in the table, we have a total distance of 23.75. The only way to get that is to add the two parts that give us that total. So we've got the northbound cyclist distance plus the southbound cyclist distance equals the total distance. Instead of distributing this 5/4 and working with fractions for a while, I decided to just divide by 4/5, or excuse me, divide by 5/4, multiply by 4/5. That would wipe out all the fractions. So 4/5 times 5/4 is 1, gives me x plus 3. 4/5 times 5/4 is 1, gives me x. And 23.75 times 4/5 comes out to a nice whole 19. X and x is 2x, so I have 2x plus 3 equals 19. Subtract the 3 from both sides, 2x equals 16. Divide by 2 and I get 8. So the southbound cyclist was going at 8 kilometers an hour. The northbound guy is going at 3 kilometers an hour faster than that, or 11 kilometers an hour. All right, here we go. Let's take a look at number 10. Number 10, we've got g plus 12. Let's distribute the negative 2. Negative 2 times g is negative 2g. Negative 2 times negative 24 is 48. That's greater than 0. Let's combine like terms. G minus 2g is negative g. 12 plus 48 is 60. That's still greater than 0. Subtract that 60 from both sides. We've got negative g is greater than negative 60. This is a key step right here. We need to divide by a negative 1 to get positive g. When you divide by a negative, both sides by a negative, or multiply both sides by a negative, we have to reverse that sign. So negative divided by negative is positive g. Reverse the sign. Negative divided by negative is positive 60. And g turns out to be less than 60. Let's take a look at number 11. Number 11, I would start this one by dividing both sides by 2, knock the numbers down. So m minus 7 is greater than 4. Add the 7 to both sides, and m is greater than 11, and that one is done quickly. Number 12. Number 12, we have to distribute the 6. If we tried to divide, it doesn't go into the 8 evenly, so I don't want to introduce fractions or decimals. I'll just distribute and keep my whole numbers. If I subtract 6h from both sides, I can get all the h's on one side, so that'll give me 18 plus 2h is greater than or equal to 108 I should have here, 6 times 18, greater than or equal to 108. So if I subtract 18, I get 2h is greater than or equal to 90. When I divide by 2, I find that h is greater than or equal to 45. And we're done with that one. And then number 13 here. Let's go ahead and subtract 4b from both sides. We're trying to get all the b's on one side. That'll give me negative 12 is less than or equal to 26b's plus 14. If I subtract that 14 from both sides, that'll give me negative 26 is less than or equal to 26b. Divide by 26, and we get negative 1 is less than or equal to b. If I turn that around, I get b is greater than or equal to negative 1. Notice this says b is the bigger number. This says b is the bigger number. When you turn that around, sometimes it's good to check and make sure you don't lose what it originally said. Solve some absolute value equations. In this equation, I've got the absolute value in here. I'll deal with that right at the end, this absolute value. I'll deal with everything else just like it said 6x minus 10 equals 26. So I've got add 10 to both sides. So that gives me 6. Absolute value of n is equal to 36. Divide both sides by 6. Absolute value of n equals 6. That means I could plug in a 6 or a negative 6 right here and get the absolute value of it to equal 6. So there are two answers. Remember, there are two answers to absolute values, usually a positive and a negative when they're simple like this. When they're more complex like number 15, that's not necessarily the case that you're going to see the same number twice like that. Here we've got the absolute value that I need to isolate, so I need to get rid of the 7. We're going to divide that from both sides. So absolute value of x plus 1/2 is equal to 2. Now we're going to do our cases. Case 1, x plus 1/2 equals 2. Remember, case 1 just drops the absolute values and write everything down. Case 2 is x plus 1/2. That stays the same. Equal stays the same, but we change the other side, the negative 2. The absolute value can equal the positive or negative value of 2 before we take the absolute value. After we do, it'll be 2. So we can set this up. Subtract the 1/2 from both sides. 2 minus 1/2 is 1.5. So we've got case 1 solved. Subtract the 1/2 from both sides. Negative 2 minus 1/2 is negative 2.5. So here are my two solutions. X could be 1.5 or x could be negative 2.5. We weren't asked to graph, so we're done there.